Okay, now we are ready to show how we combine like terms and do a couple of practices. So remember that step one is to write the problem. So if our problem is A plus B plus 2B plus 3A. We have our problem written. Over here, we're going to just practice giving a justification. This won't be crucial, so if this part makes you frustrated or confuses you, just try it and keep working at it. But it will help you to get to know your properties better and to understand the whys we're allowed to do the things we're allowed to do. So I would like you to attempt it. So the justification of writing this is it was the given problem. So when you write the first problem, you just always write it's given. Now, step two, I'm going to code my like terms and the sign that is to the left of them. So I see that I have an A here. I'm going to use a circle. That's an unlike term, and here's another variable A. So I'm going to code that with a circle as well. Now I have a term B, so I'm going to code that with a rectangle and the sign to the left of it. And here's another B. I'm going to code that together. So now my job is to get the like terms next to each other so that I can see what I'm dealing with and I can combine them together easily. So I'm going to rewrite this saying A plus 3A, because those are my two circles, plus B plus 2B, and sometimes if I have a lot of terms, as I write them, I'll go ahead and check off that I have them in my problem so I can see that I have accomplished everything. Might be a helpful hint for you. Now I have to justify why I was allowed to change the order of these without knowing and making sure that I did not change what this problem was going to equal. The reason I'm allowed to change those is because we learned in the commutative property it doesn't matter which order I add these numbers in, I will still end up with the same numbers. So my justification here is the commutative property. So now my job is to simply combine the like terms. So if I have one apple plus 3 more groups of apples, that means I have 4 groups of apples. Plus, I have 1 banana plus 2 more bananas means I really have 3 groups of bananas. And why I'm allowed to do that is simply, what did I do? I added. Now, I do not have any other like terms. I cannot combine apples and bananas. They are 2 different things, just like groups of A are different than groups of B. So that is as simple as I can get, and I have finished combining my like terms and simplifying the expression. Let's try another one. First, we're going to write the problem. We're going to have C plus 2B plus 3C plus parentheses 3A plus 3B. Again, that is our given problem. So now we need to code the like terms. So here I see a C here, and no more C's. Next, I see B's, so I'm going to give those a rectangle, and then I have an A. So now my job is to get these like terms together. Well, this is kind of tricky because I have parentheses and a different order. So what I see here is I have B's and B's I need to get together, and I don't have any A's I need to get together, and I have these C's I need to get together. So I'm going to use the commutative property to rewrite these in a different order. I'm going to write C plus 3C, got those. Then I'm going to add the 2B plus this 3B here plus the 3A. So I've done the 3A, I've done the 3B. So why was I allowed to change the order of all of these items? The commutative property tells me that's totally fine. It's not going to change my outcome. So now I have this issue that the order of operations says that I need to add these two together first, and I'm really stuck because these are unlike terms and I can't combine them. However, we learned about the associative property, groups together, and it said I'm allowed to change what is grouped together if they are being added or multiplied together. So the next thing I'm going to do is go ahead and change these groups, applying the associative property, to this 2b and 3b instead. So I have c plus 3c plus, I'm going to change the groups to be 2b plus 3b plus 3a. Why was I allowed to do that? The associative property. Now that I have everything lined up together and grouped together, I can go ahead and combine like terms. So if I have 1 coconut and 3 groups of coconuts, I really have 4 groups of coconuts. Remember, anytime you have a variable by itself, it has that imaginary coefficient of 1. It means 1 coconut. So when we add the 3c and the c, that's how I got the 4c. Plus, I have 2b plus 3b, which would be my 5b. I can keep the parentheses there if I want, or since I've done the operation inside of them, I can go ahead and let it go. Plus 3a. These, nothing else is like terms, so that's as simple as I can get. And all I did here was add. So notice how nice this is to solve compared to this expression up here that has 1, 2, 3, 4, 5 terms, and now we're down to just 3 terms. A lot easier, especially when we go to the solving portion. Let's do another example here. If I have 2 parentheses x plus, plus 3y minus 2x. That's my given problem. So now when I'm looking at this, I'm noticing, well, inside again the parentheses, I can't do anything with that because they are not like terms. However, I noticed this 2 outside here, which means I could apply the distributive property and pass out the groups of 2 first. So that's what I'm going to do here, is I'm going to pass out the groups of 2. So I end up with 2x plus 6y minus 2x. Why was I allowed to pass out those groups of 2? Because the distributive property taught me I can either add this first, then multiply the total by 2, or pass out the groups of 2, then add them together. So now let's identify like terms that I need to combine together. I have a 2x here and a minus 2x, and then I have a plus 6y. So how can I get those things together? Well, technically, I have to first do the commutative property to get these next to each other. So I would have 6y plus 2x minus 2x. Why was I allowed to change their order? The commutative property. Now, I need these to be grouped together. Well, how can I group these together? If these are already grouped together, the associative property allows me to change my groups. So I'm going to do 2x minus 2x and just change my parentheses there for my groups. Now, so that's the associative property. Now I can combine like terms because I have 2x minus 2x. Well, if I had 2 xylophones and then I lost 2 xylophones, how many xylophones do I really have? 0. So now I have 6y plus 0, which applying the identity property tells me that I really simply have 6y. So look how simple that problem ended up being, going from here to realizing I don't even need to discover what x is because they cancel each other out. So this simplifying stuff can be very helpful. identity. And then, so our main goals when we are simplifying expressions is to get like terms together and to combine them. Remember, we need to be able to identify like terms quickly, and we need to remember to make sure that we identify the sign that is to the left of each term. And then we want to get down as few terms as we possibly can so that our lives are easier when we learn how to solve for these problems. Tomorrow we will practice going through a few more of these together so that we can walk through and you can be on your own when you begin simplifying expressions. Have a good evening. See you tomorrow.